attack. And right now I'm just removing all of the hashes that I did prior to doing this video. So I'm going to go to tools and I'm going to go to hash calculator and I'm going to put in a password, and I just used password 1. And then basically right now I'm picking any hash algorithm, and I was going to use MD5, but that's kind of weak. SHA-1 is weak as well, but I just wanted to like switch it up for the video purposes. So I'm using the hash algorithm for that password, and then I went to SHA-1 and added that the hash that I got from the calculator into the SHA-1 hashes. So I'm going to go ahead and run dictionary attack. And right now what I'm doing is I'm going to go to my file and I'm going to go to add to list, and I'm going to go to word list, and that's just basically a predefined set of words that Oxid gave us when we installed Cain and Abel. And I'm going to leave all the defaults as they are, and I'm going to start this. Let's use the key rate, the dictionary position, and then it also tells you the percentage, and it's looking for like a current password right now. And as you can see, the plain text of that hash is password 1, and they cracked the password. So now I am about to do another dictionary attack using a SHA-1 hash, and this is just to show you all that that it doesn't work when you use any letter or symbol that is not within the dictionary. So I'm just going to go ahead and go back to tools, and I'm going to go to hash calculator, and I'm going to put in another text, and I just put in password, but instead of the A I use the @ sign. And I went ahead and got the same hash from SHA-1, and I went ahead and added that into the SHA-1 list. And now I'm going to run the dictionary attack on that. And right now what I'm doing basically here is Cain and Abel. They just start you off where you left off at, and I just kind of want to restart it. So I'm going to reset to the initial final position. And I'm going to keep all the default values the same, and I'm going to start the dictionary attack. And as you can see, it shows you the key rate, the dictionary percentage, just 25% now. And then it goes through passwords. And as you can see, the attack was stopped and 0 of 1 of the hashes was cracked. This is because, again, that @ sign that I used and the original password. Okay, so what we're about to do now is a brute force attack. So I'm gonna go and use that hash that wasn't cracked and use a brute force attack on it because dictionary attack didn't work. And basically we want to pay attention to our predefined values, and since we pretty much know that the password we're using is password with that @ character, lowercase, uppercase, and numbers, I'm going to go ahead and select that. So it'll be this one here. And I mean, it's to our advantage that we know the password length, and we know the password is no longer than 9 values. So I'm going to go ahead and make that 9 values. And then you also want to pay attention to your key space here. And this is going to take probably a long time because it's going through basically any possible combinations that it can. So I'm going to start this. So it's giving you the key space, key rates, time left, and it's telling me 570 years, and it's just, changing. But for this purpose, I am going to create a new hash here. I'm going to go to hash calculator. I'm going to type in ABC, and I'm going to calculate it. I am going to use MD5 because MD5 is a little quicker than SHA-1. I'm going to copy that and paste it under the MD5 hash. I'm going to add to list. That's okay. I'm going to go back here and start that brute force tag. And we're just going to do the regular ABC. And then we're going to go to 3 characters and hopefully it speeded up a little bit. The key space is 47,988. And let's go ahead and start. So yeah, it was able to get that really quick. So the plain text of that hash is ABC. 1 of 1 hash is cracked. So the brute force attack worked really fast on that for those purposes. However, if you wanted to do something really long, you see kind of like how long it would take to crack a password with multiple characters, uppercase, lowercase, and a number.